Introduction. Design challenge. What challenges do those with arthritis have when engaging with a computer at a desk? Are people currently using any alternative methods, like eye tracking, voice commands? Is the traditional mouse still relevant? What are some pain points, both literal and conceptual, that users are encountering? A traditional mouse is still the most commonly used device at a desk. Arthritis only has an impact on older populations, and I should focus my research on this demographic. By focusing on hand pain, that is the best way to reduce discomfort felt by users who are using traditional mice. Research phase. I wanted to understand what issues do users have when using traditional and ergonomic desktop mice. So I talked to Dr. Brian Dyke. Brian is a rheumatoid specialist in Portland, Maine, who has over 26 years of experience in the medical field. I interviewed Brian and found some interesting takeaways. Brian told me that hand and arm pain is really a spectrum, and there are many different reasons a patient can have pain. Hand and arm pain can also be caused due to pinched nerves, sprains, tendinitis, elbow bursitis, repetitive overuse, rotary cuff injury, or arthritis. Also, arm pain can impact many different age groups. Using a computer can be troublesome for patients because it can cause pain not only in the hand, but in the forearm, elbow, wrist, and even shoulder. When we look at what is arthritis, arthritis is defined as an inflammation or swelling of one or more joints. It can describe more than 100 conditions that affect the joints, tissues around the joint, and other connecting tissues. After completing some initial brainstorming, I called back Dr. Dyke and gave him my initial idea. Basically, the idea was that one would let their hand dangle by your side and a user would interact with a trackpad. This would be a mounted device that could attach to your desk or perhaps even your chair. My theory is that by allowing your arms to dangle, there is no contact with the table, and this reduces the physical pressure being exerted on one's elbow, forearm, and wrist. Dr. Dyke returned my call and said that the design approach was in fact unique. In his estimation, nothing comparable was currently on the market. However, he did say that this design could actually cause pain. By letting an arm dangle for that long, you can actually cause more strain. There's not enough stability, and there is no real way to adjust the unit. So even though my initial idea had some issues, at least I now had an idea of what I wanted to do, which was develop a device to aid in relieving arm pain for users at their personal computers. I was able to meet with 5 participants who each had varying degrees of arthritis. They had pain and numbness in their elbows, fingers, wrists, and forearms. They had stiffness in joints, sometimes requiring rest periods to regain mobility or mitigate pain management. Some of them had to switch between their left hand and their right hand for different tasks. One user made a note of rubbing her hand constantly throughout the day with heating pads, or even submerging her hands in hot water to make the pain dull. Something I noticed in more than one user was the prevalence of elbow bursitis, which is an inflammation of the fluid-filled sac, the bursa, which causes pain and limiting movement. I found this fascinating for a few reasons, which I will come back to later. Product development. Competitive analysis. I originally thought that I wanted to redesign a trackpad or a mouse, and then I realized something my user had said. This user had complained not only of hand pain, but of accompanying elbow pain. I began to think that by focusing on an alternative mouse design, maybe that was the wrong angle to take. Perhaps by focusing on a device to support the entire arm and elbow, that might be a better way to approach this problem. Here are some common arm support devices that are currently on the market. I wanted to see what the common element that links all of these things together was. It appeared to me that there was no ability to alter the variable pitch of the rest's height. Remembering my conversation with Dr. Dyke, he had said, having your arm in any position, no matter how comfortable, will eventually cause some form of discomfort. By being able to modify the position of this, the user has great customization and, in turn, less pain. Looking at these devices, we can see what things are positive and what things are negative. Once again, the ability to raise the height of the device, I believe, is key. Taking a look at another device, we'll see that you do have the ability to adjust the pitch, but once again, you cannot bring the entire device upward. After I formulated a rough idea of what I wanted to do, I began to physically sketch ideas that I had for this project. I looked into not only how it might look, but questions I had along the way, along with considerations of things that would be good to think about. At this point, I began to create some preliminary CAD models in the browser-based software known as Tinkercad. Tinkercad is great because you can edit your CAD files anywhere in the world. The only drawback is that you're restricted to a certain file size. My first model was to basically create a cradle for one's arm to sit in. This idea incorporated the same concept, except for the fact that the cradle would raise its height. This was done in order to relieve pressure off the elbow. By having the elbow at a downward slant, that could relieve pressure from the bursa sac. I brought these designs back to the folks that I had originally interviewed at the beginning of the project. Here are a few thoughts that they had. My next step was to take the feedback and try to implement it into the design. I went back into Tinkercad and made some modifications for how the design might work. My idea was to keep the arm cradle, but to make it a device that had the ability to not only augment pitch, but to be used completely flat if they wanted to remove the cradle. Next, I took a piece of my original design and repurposed it for this part. The basic mechanism is one single plastic screw that can hold the device onto the edge of the table. For this section, I utilized the rendering tool Fusion 360. What was nice about Fusion 360 is that I was able to simply export my file from Autodesk Tinkercad directly into Fusion 360. From there, I chose materials, lighting, and various ways of how I wanted to control the rendering process. Here are a few select quotes from the users when I showed them my improved design. From here, I went back into Tinkercad and tried to make some adjustments based on what the users had told me. I made the cradle so that it had the ability to move both backwards and forwards. I also elongated both sections, measured them to be the same length, and understood that this would provide more stability when utilized in a purely flat or horizontal position. For my final prototype, I added some missing pieces that users had mentioned. For the arm cradle, I made it a softer cloth. For the piece below the cradle, I made it a light fabric. For the wrist rest, I turned that into a softer gray fabric as well. I also included the variable pitch height as a way of letting the user have the ability to dangle their wrist off the edge, thereby relieving pressure on the wrist. For my next steps, I would like to install a battery that would allow the arm cradle to heat up, thereby relieving pain.